Welcome student. Now in this video class we will learn more about how we convert decimal to other system. We have already seen how we could decimal convert decimal to binary, okay, and this is how we did it, okay, in the previous video class, okay. Now if you have to convert to octal or hexadecimal, so you will do the same. So together, if you use this technique, okay, you can always apply the same technique to when you convert decimal to any other system. So when I say other system, it would mean binary, octal, or hexadecimal. So basically, conversion is from our human number readable number system, which is decimal, which we are using, to other number system, and also from other number system to the one that we use, that is a decimal. So since we have already learned about how we convert decimal to other systems, it should be very easy for you to apply the same technique to convert decimal to octal as well, and decimal to hexadecimal also, okay. So but remember, the same technique is applied for all, okay. That is, we convert decimal to other system using this LCM method that you see, right? So I've already done, we have done this together, okay, how we converted that 25, which is a decimal, to binary by dividing it, okay, and then getting the remainders. So the same way, if you have to convert the same number 25, which is a decimal number, but this time you have to convert it to octal, okay, then you have to divide by 8, not by 2 anymore, okay. So if you just do this exercise again, so if I have to divide 25, I will say 8 into 3, which is equal to 24, right? So when I say 24, what is the remainder that is left? Is only 1, okay? And then we still keep on dividing unless and until the quotient becomes 0. So 8 is too big for 3, so straight away we go to 8 zeros are 0, and your remainder is 3. So remember also that every the answer we always take from bottom to up, okay, bottom top, like that, okay. So in that way, which means your answer will be, therefore 25 10 will be equal to 31. Yes, we take 3 then 1, okay. So there you have the octal, okay, number 35 31, okay, which is equivalent to 25, which is in decimal. So the same number, if you take again to convert to hexadecimal, yes, you are going to divide by 16. So by 16, of course, I have to go by 1 itself, because 16 ones are 16, and that's when you're going to get 9 as your remainder, isn't it? Because 16, 25 divided minus 16 would be 9. And then again you have to divide unless and until your quotient becomes 0. So you go 16, zeros are 0, and that's how you get the remainder as 1. So again, same way, if you have to put this as the answer, you are going to write 25, which is a decimal, is equal to 19. Yes, that is from bottom to top, okay. 1, then you take 9. That is your answer. So it's a same technique is applied for all, right? So the next thing that we're going to discuss today is the fractional part, okay. Fractional part means a number which is like this, which is after when you have a decimal point, okay. So if I take just the fractional part, so I need to put a 0 so that you see that it is a fractional part, okay. So if I don't put a 0, then yeah, I can just write just a dot and 1 2 3, but of course this means a fractional part. Now of course the method here is a little different from the technique that we use up there, okay. So here what we're going to do is we are going to multiply, okay, and this apply to all. Again, convert decimal to other system, which means to all other system, binary, octal, hexadecimal, we are going to use the same technique, but this is just for fractional part. Fractional part, this is how we do it, okay. Let me just take it to the next page together, okay. So we take the number, the decimal number, like in this way, and then we multiply by 2. Why? Because I want to convert it to binary. So I will have to multiply by 2. So when I multiply, I say 2 3s are is 6, 2 2s are 4, and 2 1s are 2, right? So you simply have your answer as this. Okay, so your answer is this, and this goes as your answer here. So it's equal to, that is 0.246, but doesn't end here. Okay, unlike here, we always end the LCM when the quotient becomes 0, as you can see, when it becomes 0. But here we don't do that. At the most you can do 3 times of this multiplication, and that would be your fractional part that you can get. All right, so this is the first time, so let's do the second time again, but this time we take again 0.246. Okay, and again I will multiply by 2. Okay, so 2 6 are 12, so 1 goes as a carry here, so 2 4s are 8, with that 1 it'll be 9. Okay, then 2 2s are 4, so that's how you get 4. Okay, and then I write the answer back here again, that is this one. Okay, and if you multiply by 2, this is how you have this. You can consider this table that I'm doing is just as a rough work, okay, but actually this is how you have to write, equal to 0.492, right? So the answer, again, as I've said at least 3 times if we can do this, so I'm going to do this 3 times. So one more time, I'm going to multiply, but I am multiplying the fractional part. Remember, even though if you get 1 here, okay, or any number, that will not be multiplied, okay, but since we don't have that, so it's 0 only. Otherwise you have to change that to 0. So 2 2s are 4, okay, then 2 9s are 18, right? So we keep 8 and 1 goes up. Then 2 4s are 8, then 8 plus that 1 will be 9. Then this is your answer, isn't it? But then we can, but the answer actually is your, the integral part, which is this side. Okay, that is your answer actually. So I think I will choose another number where I can show you, say 49, to show you how if we have a different 1 or 2, okay, then how do you do the multiplication? Because of this we have, this is the answer, okay, but actually the answer that you have to take is this part, that is the 0 0 0 and 0, but this time we are not going to go by that bottom up, we have to take from up, from top to bottom, so 0 0 0, so it won't make sense. Okay, so we can have some, I'll take another example where I can show better. So let me take 7 here. Okay, maybe here I'll take 4, right? Maybe, right? So if it is another number, that is 573, 0.573, you have to convert to binary, then of course here it'll be 5, and this will be 7 3. Okay, then you multiply by 2. 2 3s are 6, 2 7s are 14, 2 5s are 10, then 11. That's when you have 11, and this one here will go here, which will come here, right? That is your answer. So that your answer now will be 1, and then will be 1 4 6. Okay, now if I have to multiply, again you're rough, in your rough, this you make it 0 again, because I'm not multiplying that one. Actually, I want to multiply this part, that is your fraction part. So 2 6 are 12, and then 1 goes as a carry, so 2 4s are 8, then 9, 2 1s are 4. So the second answer is same. Okay, and then now we come to the last, that is 2 2s are 4, then 2 9s are 18, and then 2 4s are 8 and 9. So you see that now you have the answer as 100. So when you write the answer for this, of course, let me just, you are going to write in this way again. So as I've said, that's a rough work. So you'll say therefore 0.573, okay, which is a decimal, it's equal to 0.100, which is a binary. Okay, because we are multiplying by 2. So this is how we convert the fractional part from decimal to other system. So if you have to do that the same way with the other system, that is the same number, that is 0.573, and you have to convert it to some other system, that is octal and hexadecimal, you will use the same technique, except that you will have to multiply by the base of that particular number system. Suppose if you have to convert to octal, then this has to be 8 if it is 8. If it is hexadecimal, then you'll have to multiply by 16. So this one I'll leave it up to you. Okay, to as a homework you will do the same. Okay, you will convert 0.573 to octal and 0.573 again to hexadecimal using the same technique. Okay, so thank you.